Welcome to you all. Continuation to the previous lecture. Today we will study about soil structure. So, what is soil structure? If we recall, we have known that the primary particles like sand, silt and clay, they don't exist individually or don't exist as such. They bind with these your cementing agents, become secondary particles, or we can say aggregates. So simply if you want to define soil structure, you can say the arrangement of different primary particles, okay, and their aggregates into a definite pattern. These things we will discuss how this will be arranged in a definite pattern. So this is simple, very simple. Okay, coming to two terms which are normally used in this soil texture chapter, texture and structure chapter, we normally see some pairs. What are the pairs? These are the natural soil aggregates. In the presence of soil aggregates in natural conditions, we call them as pairs. Okay. Then, if these pairs break down, become shorter particles in natural condition, we can call them fragments. Simple. Okay. Then another term which is normally used, one is clod. What is clod? You know what is tillage. So while by doing tillage or some artificial means, the soil mass becomes coherent mass. Okay, becomes coherent mass because of artificial activities like tillage. We call them as clods. Okay, very simple. We have normally observed in field conditions. Coming to another term, which is concretion. This name itself, you can know what is concretion. Because of precipitation, the soil mass becomes more hard, the aggregates become irreversible. Okay, these become concretes. So this is normally this type of words used. So after that, if you want to classify different soil structures, the classification are mainly based on three bases. Based on their arrangements, we call them as type of soil structure. Based on their sizes, we call them as classes of soil structure. Based on their strength or durability, we call them as what? We call them as grade. Okay, if we do classification, normally three types. I am not writing this, but if you see the type of soil structure based on mainly the arrangement of soil structure. So there are also two types. One is simple, one is compound. Simple are mainly two types: single grain and massive structure. In single grain, what happens? The sandy particles, post-texture particles I discussed, these becomes the single grain like structure. Okay, in massive soil structure what happens? The clay we have discussed, they become such a coherent mass, they become forming the massive soil structure. Okay, this is very normal. Then coming to different compound type of soil structure, we normally can observe in field conditions. Okay, coming to compound soil structures. In type of soil structure, okay, in type of soil structure, coming to compound soil structures, we have normally seen four types. We see one is block-like. Block is normally cube-like. Okay, you draw. This is a cube-like structure. Okay, This is, you can say, angular blocky. Angular blocky. Here you can see there is a horizontal axis, there is a vertical axis. Here you can say the horizontal axis and vertical axis are equal. And in case of angular blocky, the structure is like cube, but the edges are not sharp. Okay, this type of soil structures are normally seen in field conditions. So angular blocky. If you ask, so where we observe this type of soil structure mainly? Mainly we observe this type of structure in B horizons. The subsurface horizon we discussed in soil profile. Normally in B horizons we get this type of soil structure. Just remember, there in block like also two types of categories are there. One is angular blocky, another one is subangular blocky. In angular blocky, the edges you can see, edges and faces, edges are normally sharp. Okay, and here the edges are not sharp. And then coming to another type of soil structure, we can call them bridging line. Okay, we normally draw this type of figure. We will get this type of structure. This is more of bridging line. Okay, here we can see the vertical axis is more as compared to the horizontal axis. Okay, then in this category also there is some category which is columnar. This is bridging line, but you can see the topmost portion is not sharp, it is angular. So this is columnar soil structure. Okay, and another one is plate line. Here also there are two subcategories. One is platy. We can say here the horizontal axis. We can see the horizontal axis is more compared to the vertical axis. Okay. Here we call it as platy. Another subcategory is there, platy, and then is laminar. What happens? Here the plates are normally thick. I have said what is plates already. Plates are aggregates found in natural condition. So here the natural condition kind of plates are normally thick. Here it is the plates are normally thin. Plates are normally thin. Okay, and we can see the horizontal axis is more compared to the vertical axis. And another type of structure are spherical. These are the most important for our agriculture point of view. Okay, spherical form, we can say they are given in granular form. Okay, and if you see the most suitable for agriculture and more porous structure, we can say them from this type of structure. They are like regular spherical particles. Okay, we can call them as Crombie soil structure. Remember, these type of structure are the most suitable for agricultural point of view. So we have seen. I can also show you. Just see, these are the type of structure. We can see this is kind of platy type of structure. You can see the horizontal axis is more, okay, compared to the vertical axis. Where we find this type of soil structure? We find this type of structure mainly black soils of India. We have studied different soils of India. Mainly black soil regions. We found this type of platy structure, and dominance of clay is also there. In clay dominated soil, this platy type of structure mainly found, and the prism-like structure found where? In arid and semi-arid regions of India. Arid and semi-arid region, where there are deserts. Okay, this type of structure is generally found. Okay, and spheroidal type of structure where we found generally at agricultural field. Agricultural field. Okay, so this structure we have normally seen this type of structures. Okay, you can see this is a type of granular. This is type of crombie type of structure. Okay, we see this is kind of prismatic structure. We can see the vertical axis is more compared to the horizontal axis. Like this way, there are also two type of soil structure classifications. One is here based on size. Okay, and another one is based on your durability or strength. We call them the soil grades, structural grades. I am not discussing here. This is very easy. If you follow your textbooks, you can understand. Okay, now coming to the most important part of this soil structure, that is your genesis of soil structure. This is the most important. This genesis students most often get confused. How the soil structure develops. Okay, normally what is genesis? Genesis means how the soil structure develops. So if we see genesis of soil structure, this is the most important. Okay, you can say this is a three-step process. What happens? What are those steps? First step is there will be flocculation. Okay, then there will be cementation. We'll see step by step. Don't worry. Then last step is you can say disruption. Let's see step by step. So what happens in step 1? The individual particles like clay, sand, or serum particles, they remain in dispersion because of high zeta potential of these clay particles. They try to repel each other. Then the clay particles carry negative charge. So what will happen? The negative charge will be balanced by different cations or anion molecules. So different cation molecules first involves formation of floccules will be there. So you can say primary particles are there in soil suspension. They are in dispersion stage. Then these primary particles, you see the reaction. Your clay was negative. This will attach to water, and there will be cations. Cations may be aluminum, iron, like this. Cations carry positive charge. Then it can form a clay particle. Then we can write water also, like this way. Like this way, we can write. Okay, so what? There will be formation of clay domains. We call them as clay domains, or formation of floccules. What happens here? These floccules normally forms because of different van der Waals forces of attraction, and we can say covalent bonding. Okay, these are some intermolecular or intermolecular forces which act on these primary particles. So they will get binded by the cations or anions, forming floccules. This is the step 1. Okay, this is the step 1 where there is formation of floccules. There is formation of floccules. Here what happens? Here the now the zeta potential is reduced. Zeta potential is reduced. Earlier the zeta potential was higher. The particles become floccules. Then comes the second phase, which is cementation. For cementation, what requires different cementing agents? You know. So coming to the cementing agents, the first cementing agent we can say most important one is organic matter. So when organic matter dissociates, but it forms humus. If we see also fractionation of organic matter, this humus also consists of humic acids, fulvic acids. Okay, what they carry? They also carry negative charges. Also, I can say this organic matter can act as alpha-type in nature, both cation and anion. We see the reaction earlier. There was cation involved. Here we involve, right, water. There will be clay particles. There will be cations and the cementing agents like this way, we can say the cementing agents just combines. Okay, cementation happens. This way, this is an example. Many type of reaction like that way occurs. So, if you see, also during formation of humus, the organism involved. Okay, they also release some substances like what? Like carbohydrates. Okay, we can say bromelain. All these organic acids. Okay, so what they also help in binding. We can say that these are transitory in nature. This type of transitory in their action. Also, there are other cementing agents like we can say your roots. Okay, roots also, there are parts like dead tissues removed from roots. There will be your secretions, exudates, mucilages, exudates. These type of substances are released. These also helps in binding or cementing the floccules or clay domains. We have already found floccules. So this will help binding in floccules. So we can say these are very temporary in nature. Now all these we have discussed. This cementing agent in a broad way you can say biological way. Then coming to the tropical region, we have seen the iron aluminum oxides. You can name them one cementing agent. I can say another type of cementing agents. Iron and aluminum oxides. Normally these are found in tropical regions. And another type of cementing agents we can name calcium and calcium carbonate or this type of substances, exchangeable cations. Okay, and also presence of clays. They also itself acts as cementing agents. So what happens? Now the cementation process is complete. So cementation is now complete. All the cementing agents form binding the, we can say clay floccules or clay domains. I am writing is floccules. It is easy to remember. Actually, this genesis is most often confused by students. We are seeing this that's why in a step by step ways. So it will be easier. So after cementation, there will be formation of micro aggregates. We can say normally the size of the micro aggregates are 20 to 250 micrometer. My PhD work I also done on this macro aggregate or the aggregate fractionation. Okay. Then after formation of micro aggregate, there the process comes what? That disruption. In disruption, what happens? There will be fragmentation, or we can say rearrangement. Fragmentation, and we can say rearrangement of particles happens. So what are are the external processes? This helps in disruption of particles. External process, we can write down them as tillage, wetting, drying, freezing, thawing. This type of external process, those simple micro aggregates are fragmented. I have already discussed this in weathering chapter. Okay, in weathering we have discussed how physical weathering, there is wetting and drying, affecting large rock particles to smaller fragments. Like that, the micro aggregates now becomes fragmented, and there will be rearrangement. Okay, then finally there will be formation of your macro aggregates. So these macro aggregates normally have size more than 250 micrometer. Okay, this may be up to 5 millimeter. This may go up to 5 millimeter. Okay, so after the macro aggregate formation, then we can say the soil structural beds are formed. You can name them as beds. Okay, or soil structure. Now we can include like this type of beds we can see, like blocky structure, your periodical structure, blocky, prismatic. Already I have discussed this type of soil structures. Now you can see in a field. So if you just summarize, you can know there is step 1 is flocculation. You can see formation of clay domains and floccules. Then in second step, what we have discussed in second step, there will be cementation, and in third stage we have seen how because of disruption there will be micro aggregates rearranged and formation of stable macro aggregates. These macro aggregates then give rise to the beds. This is the whole process. Okay, just remember, this is the most important part I think to understand in this soil structure chapter. So now, coming to this, now we have done the genesis. Then what are the factors affecting? We see generally the factors affecting soil structure formation. We can say factors, divide them as soil factors and your external factors. Okay. In soil factors, we can say texture. Okay, there are different soil factors and different this you can get from your textbooks also. I am not going through this detail. The class will be otherwise more lengthy. So, if you see soil factors, one is texture, another one is your clay mineralogy, another one is your adsorbed cations, and organic matter. In external factors, we can say the climate, your biological factors, then your management practices like tillage, etc. Management practices, what are the crop grown, tillage practices, all these things included in your management practices. Simple, you know, texture, there are coarse textures and fine texture soil. So which type of textures? If they are, there will be more formation of stable aggregates. Generally, fine texture soils. Very simple. Clay mineralogy is, when you will study clay mineralogy, you came to know the details. Now generally know, there will be 2:1 clay minerals, 1:1 clay minerals, like that. Okay. So presence of 2:1 clay minerals, there will be formation of stable aggregates compared to the 1:1 clay minerals. Okay. If come to the presence of cations, we know the more valency, this will adsorb the cations, this will adsorb the floccules or cementing agent, acting as a cementing agent. This will give more flocculating power. Okay, like your trivalent cations, aluminum will give more structural stability compared to your calcium and magnesium. And calcium magnesium will give more structural stability or flocculating power compared to your monovolatiles like hydrogen, etc. Hydrogen, sodium, etc. Okay. Organic matter we have discussed. The more the organic matter, the better will be soil structure. Okay. Coming to climate, these are external influences. We know if the climate is very harsh, the development of structure will be less. If the climate is very favorable, okay, like in the rainfall will be there, optimum temperature will be there, so microorganism population will be more, so the soil structure will be good. Okay, the bed formation will be good, or more formation of, we can say, periodical or clumpy like of soil structure. Okay, biological factors we know, already discussed how the climate and biological factors are interrelated. Okay, and management. This is also self-explanatory. Like if we do more tillage, okay, the breaking down of structure will be more, so there will be formation of more clods or your concrete type of materials. Okay. Now, if you want to evaluate the soil structure, now we have classified and seen the genesis and factors affecting. If lastly, if you want to evaluate the soil structure, there are evaluation of soil structure. If you see, there are some microscopic methods and some macroscopic methods, or we can say these are coming in direct method, and there are some indirect methods are also there. Okay, this is direct method is very simple. We just keep it at a normal height, drop on a normal plane surface, we will check the soil structural stability. In indirect structure, we have also seen different parameters like your mean weight diameter, geometric mean weight diameter, okay, change in mean weight diameter, water stable aggregates. All these parameters we can judge the structure. Okay. I am not discussing all this. I have done PhD and my PhD thesis was mainly on aggregate fraction. So I can explain these things better, but the class will be more lengthy. If we will discuss this in our practical class. But if you show more interest, I can or give me comment that sir explain this. I can explain in next videos also. Okay. So that's all about soil structure.